Alright, so our last segment is redox reactions. We have question number 3, and they want to know in which one of the following reactions A to D do we have that HCl is oxidized. So normally you will go and work with the oxidation numbers and figure out what's happening. But we want to experiment here and see if we have something that stands alone, like there. What's the oxidation numbers of that to quickly determine which one is going to oxidize or not. Alright, so here we're comparing HCl. Now remember, H's oxidation number is normally +1 in a compound, so that means Cl is minus 1. And because it's a monoatomic ion, it will have the same oxidation number as the charge. So you'll see that HCl didn't do anything. In this reaction, nothing stands alone, nor does it in C, but you'll see here in this reaction that Cl stands alone, and you'll know that an element has an oxidation number of 0. And exactly the same as with number A, Cl will have a -1. So what happened to Cl going to Cl -1 going to Cl? The oxidation number increased, so that means that's oxidation. And it's also, just for reference, it's the reducing agent. So this will be then your correct option for question 3 to be option D over here. All right. Our next question is question 6, where they just want to know what's the oxidation number of phosphorus in phosphoric acid. Okay, or well, H3PO4. So this whole molecule has a 0 charge. We know in a compound that oxygen has a -2 oxidation number, but we have 4 of them, so that's -8. Hydrogen in a compound is +1, but there's 3 of them, so that's a +3. So what is left? That is the oxidation number of phosphorus. And phosphorus's oxidation number, if we do the math, you see it needs to be a +5 to equal that 0. So the oxidation number of phosphorus will be option D, +5 oxidation number. Then our next question is question number 27. Exactly the same as question 3, the first question we had. They want to know, just want to get there in my pages. Number 27, which one shows a redox reaction? Okay, so a redox reaction, we want something to be oxidized as well as reduced. Okay, so again, we're going to look at something that stands alone, like with number 1. So you'll notice, or you should know, that silver in a compound is +1, so that means chlorine in this compound, because it's a 0 charge, should be -1. But that stays exactly the same because they are monoatomic ions, so -1 +1. So this is not a redox reaction. Remember, a redox reaction should change or have a change in the oxidation numbers. Here, if we look at copper, it's a 2+ because of the monoatomic ion, but it's also a 2+ in this compound, okay, if you go and check there. But let's see the sodium and the chloride reaction. Both of them are 0 because they are elements, but in this compound, because sodium is a group 1 metal, it should have an oxidation number of +1, meaning chlorine should be -1. So the oxidation numbers changed. Sodium increased, meaning that's an oxidation, and that's a decrease, showing you a reduction. So your correct redox reaction is then option or reaction C. Our next question is question 28, where we have the following reaction and we need to know which statement is correct. Okay, so let's go and see. So there's an easy way to see if something is an oxidation reaction by looking at the electrons. So the electrons are on the other side and the other electrons are with the reagents. So an easy one, that's your oxidation and reduction. But what if that didn't happen? Then you're going to look at the oxidation numbers. So a 0 changing to a +2, we have an increase in our oxidation number, meaning this is oxidation, or our reducing agent will be barium. If we look at, I just want to check here what I did. Yeah, if we look at oxygen, okay, you'll see that oxygen is 0, and in this molecule or a compound, oxygen is always -2. So you can see we have a change there, a decrease, and a decrease is the same as a reduction, and a reduction is also oxygen will be our oxidizing agent. You could have watched, well, this is a +1 and hydrogen stays +1 in a compound. So your correct options or statements will be then in D, where reaction 1, barium is oxidized, just want to say D, barium is oxidized, and then that your O2 is reduced. Our next question on redox reactions is question 30. Oh, I flipped around. Question 30, where they give you hydrogen peroxide, okay, or hair bleach, as you should know. So they gave you this reaction, AgO plus hydrogen peroxide, giving you Ag plus H2O plus O. All right. So they want to know what is happening, or what is the role of hydrogen peroxide in this reaction. So let's check at hydrogen peroxide specifically. Now this is your exception to the rule on oxidation numbers. Normally oxygen is a -2 in a compound, but in this case oxygen is -1 and hydrogen is +1. Okay, so well, this is question number 30. So that's your exception to the rule. So let's see what happens to hydrogen. Hydrogen stays +1, okay, but what happens to oxygen? It changes to a 0 because it's an element. So -1 to 0, we increased in our oxidation number, so that is oxidation, or again our reducing agent. So question number 30, your correct option will be option E, that states that hydrogen peroxide, hair bleach, is our reducing agent. Yes, we just saw that. It's the oxygen that's causing it, but your reducing agent, because they're talking about hydrogen peroxide. And remember, an agent is a reagent. All right. Next we have question number 33, where they want you to complete the balancing of this half reaction using the ion electron method. IO3- changing to I. Now remember, when we did this in class, we had a rhyme and an order. Just go look it up again. So let's quickly balance this reaction using our ion electron method. Oh, just correct this. It's iodine, the diatom. Okay. So the first thing, we're going to look at if our elements are balanced. We have 2 on that side, only 1 here, so we put a 2 in front. Then we need to check the oxygens. Here we have 6 oxygens, but nothing on the right hand side, so we're adding 6 water molecules. Now automatically I have 12 hydrogens on the right and 0 on the left, so I'm putting 12 hydrogen ions there. Now I have a 12 plus and a minus, so I have an 11 plus charge on the left. Is it correct? Yes, 11 plus and 12 and, oh sorry, we have a 2 in front. A 12 plus and a 2 minus, so it's a 10 plus. Sorry, a 10 plus on the left and a 0 on that side. So on what side do we need to add our electrons? We're going to add our electrons to this side, and we're adding 10 electrons so that we have a 0 charge on both sides. So the correct balancing using our ion electron method was option D. And then that is it for all your questions, and I hope you enjoy.